Good evening, everyone. My name is Amit. This is Gate Physics live sessions phase two. This is the second week we are meeting. We in the last week we talked about special theory of relativity, and this week we'll continue with the same. Hopefully in the next week and the next week after that. So first 4 weeks will be special theory of relativity. We'll wait for a few minutes. People usually join till 7:05, and even after that. So we'll wait for a few minutes, and then we'll start the session. Thank you. In the meantime, if you have any doubts from the last class or any comments, you may ask. Um, since people are joining, we can utilize this time to, or not just doubts, anything you want to talk about in general, like the gate exam in particular, or maybe the net JRF and other things. So you're free to utilize this time however you may want. Otherwise, we'll start at around 7:05 p.m. Thank you.
Sir,
Yeah,
good evening, sir.
good evening.
Sir, can you please share the links that are given before because this is my first class that I'm joining.
Okay, so what I'll do is that I should make this a practice. So what I'm doing, I'm going to write down my email ID and the YouTube channel on which these are posted. So just hold on a minute, I'm writing down. So this is my Gmail ID, and the YouTube channel is with the same name. So the YouTube channel is, I'm now typing the YouTube channel name. So YouTube channel name is also Learn with Amit Bansal, and the email ID is learnwithamitbansal@gmail.com. So for the last session on special theory of relativity, I have uploaded the lecture. I think I uploaded it 2 days ago. And for the previous 12 lectures, in which I covered all the topics of electronics, every question of electronics was covered from 2022 back to 2012, I think, or 13. I'm forgetting. But for the past 10 years, I covered questions of electronics, some part of semiconductor, solid state physics, because there's an overlap in semiconductor topics. So I think one lecture was related to that. Otherwise, electronics is completely covered. So you can go through these lectures. If you have any doubts or any comments, you can comment on the video itself. But if you feel that you have a specific query, then you can email me on this email address which I have shared with you. Right. So yeah. Okay.
Yes, sir, thank you.
Yeah. So we'll wait for one more minute and then we'll start. Anybody else? If you have any comments regarding the topic itself or in general, regarding the. Okay, I hope you went through the syllabus once. So FETs are important for gate and net. Gate, Amit, gate. There are. I mean, every alternate year a question is asked. So what you need to do is you need to go through that whether it was asked in 2022 or not. Just see for the past 2 or 3 years. Usually what happens is FET. Okay, FET we are talking about is junction FET. First of all, it's not MOS FET, which is metal oxide semiconductor FET. So in the syllabus, it's junction FET, which is I should say a simpler device, because there are less things to be considerate about in JFET as far as gate exam is concerned. In net, I am forgetting, because I've not. I've not gone through the syllabus of gate, but as I always say, my advice to you is just go through the previous year questions and the syllabus. These are the two most important, beyond any textbook, beyond any coaching center or any live session. What is most important for your preparation is the syllabus and the previous year questions. That's it. I don't think I solved more than 5 mock test papers just based on previous year question. I knew the gate, they ask questions from which topic. Try to prepare that, and remember that the cutoff usually don't, let's say worst case scenario, cutoff will not go above 35, and easily you will get chances for you will get interview call letters, I think around 40 or 45 cutoff. So you need not even score 60 marks. Forget about preparing for 60 marks. So you just bear that in mind. Second, there was one more question. I'm very poor in BJT. Would you like to cover it? Chaudhary, what I did, as I told you in the previous live gate live sessions, I think you joined in the last two classes also. I'm forgetting. I think you joined the last class or in the second last class also. But there, if you go through the videos on the live sessions, I had covered it. So I will not be covering it again, because we need to have because the idea of these sessions by NPTEL is that we need to cover the breadth also. So let's say you have any specific, that's why I keep on telling you that you go through these videos. If you find any doubt, you comment there. If you feel that you need more personal attention, send an email to me. I'll try to reply as soon as possible. I think you dropped a comment there in the video itself, and I replied, hopefully, to your satisfaction. So that's that. Just go through those videos, and again, just whether it's gate, net, or jest, or whatever exam, just please go through what is the level of question that is asked. The level of question from, as far as for BJT, gate is different and net is different. So what level you require in gate, you do not require that level in, you may not require that level in net or just, for that matter. So just make sure what you are preparing for, rather than going through like absolute best. No, you need to clear a threshold. No. I covered BJT. I think it's in the, I'm forgetting. Let me check. Let me check the. Let me open my YouTube link where I have created that. So if I go to the content, so right now, what I'll do is I'll share my screen, and then you can see the content itself. So hold on a second. Yeah. So hopefully you will be able to see my screen. Please respond yes or no. Are you able to?
Yes, sir, it's visible.
Yeah.
Yes, sir, it is visible.
Okay, so you can see this is the lecture. So you can see, yeah, this one, bipolar junction transistors. This lecture. So this would be 11th lecture. 11th lecture, which was published on 1st November 2022. So you can go through this. Similarly, diodes is the one before it. So I had covered BJTs, so you can go through that. And this is the last week session, uploaded on December 2nd. Okay. So what I like to do now is, hold on a second. All right. Right. So now I think we have waited enough. Now we'll start the session. I'm not going to share the screen with you. Are you able to see my screen? Anyone? Hello?
Yes, sir, it's visible.
Okay. So we'll begin. As I told you earlier, gate physics phase 2. This is second live session, week 2. Today is December 4. My name is Amit. We had started last week about talking about special theory of relativity. I'll go through the concepts, just revise the concepts. Relativity, because we are defining a relation between space and time. Space we define usually in the rectilinear coordinates as x, y, and z, and the time we are defining here as, usually what we do is simply t. So it's this, it remains same here. Why is it special? Special is because we are neglecting the gravity. If we include the gravity also, it becomes general theory of relativity, which is outside the scope for gate, I think also for net. The key thing in this special theory of relativity is that the first thing is that laws of physics remain invariant in inertial frames. So which laws of physics? Laws of physics like conservation of momentum, conservation of charge, they will not change in whichever inertial frame you are. Okay, what is an inertial frame? An inertial frame is a frame of reference with zero acceleration. That means the frame either has to have zero velocity or it has some constant velocity. Means it cannot be a function of temperature. It should not be a function of temperature, because a function of temperature, it's varying with time and it will have some acceleration. And the second thing is, the second thing you need to keep in mind in this theory is that speed of light is same for all frames. So whichever frame you are traveling, whether you are at rest or you are at constant velocity, speed of light c will remain the same for all the frames. That's what we saw in the last class also. So a few key terms. What is an observer? So observer in an inertial frame is, in this case, we see this frame S, and an observer here is sitting very quietly at the origin. We call this observer O, and this is the frame S. This is an inertial frame. Why? Because the velocity is zero here. We saw inertial frame is where the velocity is zero, or velocity is constant. This is the second example. This is another frame, let's say S prime. In this case, another observer is sitting at origin, also at O prime, and this frame is moving the constant velocity v in positive x direction with respect to this frame, the first inertial frame. So again, since this is a constant velocity, let's say it's 2 I cap meters per second, right? So it's a constant velocity, it's not dependent on time. So this is also inertial frame. O prime is the observer in this frame, S prime frame. Second thing, we saw what is an event. So event is nothing but, let's say this is an event P. It can be anything, like you clap, or brakes are applied in a car. Anything and everything in this universe is an event. Me speaking is an event. Every word I speak is an event, and it's denoted by, we saw this configuration. So x1, y1, z1, semicolon, t1. This is how it will denote the events. So P is an event. Similarly, Q is another event. Let's say x2, y2, z2 are the coordinates of its space, and t2 is the time coordinate. Similarly, the same event will happen at some, let's say, p prime coordinate. Note that the notation is, everything is primed in this second frame. So here it will be x1 prime, y1 prime, z1 prime, t1 prime, semicolon here. Similarly, the q will be x2 prime, y2 prime, z2 prime, semicolon, t2 prime. Now note that in reality, P is only one event. So this observer O is saying it happened at this space and this time, while this observer is showing it happened at this place at this time. In actuality, there will be only one event. Okay, so we need to keep in mind, that in mind. Okay, so after this, what we see is, yeah, so this is an event. So P and Q are an event. So P is essentially equivalent to P prime, and Q is equivalent to Q prime. Sorry, prime here. So how are these two related? How are then mathematically, how is x1, y1, z1, t1 is related to x1 prime, y1 prime, z1 prime, t1 prime? We'll see in today's class. Last week we did not see this, but today we'll see how are these mathematically related, right? And the core of the special theory of relativity is space-time interval, which is denoted by delta S. And what it says that delta S squared will remain constant, will remain invariant in all the frames. So if we calculate delta S square in this frame and in this frame, its mathematical value will come out to be the same. And how do we calculate the value? We calculate the value using this formula, right? Delta S square is equal to C. Okay, so this slight error here. It's C delta T whole squared minus delta x square minus delta y square minus delta z square, where delta T, x, y, and z are like this. And as we talked about, how is P related to P prime mathematically? We'll see in today's class. But before, last class, a doubt was raised that why this negative sign here, right? We'll address this today first. So as I told you, a distance in physical world is nothing. Distance in invariant is a physical world. Whether we are sitting here at your desk or I'm sitting here at my desk, when we measure, let's say a centimeter, it is a centimeter, dependent whether we are moving in a car or not. It remains a centimeter. Distance is invariant in a physical world, the world as we see. However, in the STR universe, in this mathematical universe, space-time interval is the invariant. Now we'll see that why this negative sign comes. So let's assume the negative sign does not come. Straightforward. I do not know. Okay, so what I'm assuming is that, so what I'm going to assume is simply only x-axis. So without loss of generality, I'll ignore y and z, because y and z are equivalent to x, in the sense that the mathematics becomes easier. So I'll just write this for now. So it's C delta T whole square, and let's say it's k. K is a constant. Okay, k delta x square. Let's say in this frame, this is the observer here, and in this frame S, right? So I'm measuring and I'm trying to locate an event P here, which is in the coordinate x semicolon T. Okay, so I'm trying to see what is the space-time interval for this event. So I can write this expression, delta S square is equal to C delta T square. K is a constant. I don't know K. I need to determine. Okay, so we'll determine what is the value of K, and that will tell what is this relation actually, which you saw in the last slide here, that there's a negative sign here. We'll see if this negative sign comes or something else comes, right? So now let's say now P is something like an LED. So it's emitting a photon, right? So let's say this is an LED. So let's say P is an LED emitting a photon. Okay, by the way, LED is light emitting diode. What is it, how does it function, you don't need to go into that. Light emitting diode is nothing but your, like your for decorations, for festivals people hang those light bulbs in their balconies and stuff, so those are LEDs. And the bulbs nowadays are LEDs, the bright white bulbs, so those are LEDs. So it's emitting a photon essentially. So if it's emitting a photon, now photon is being emitted from this, right? So the distance required, so the distance that the photon will travel will be x. So distance, so let's say speed of photon would be distance traveled, this is 8th class physics I'm doing, distance traveled over time taken. What is the distance the photon has to travel? The observer is here, so the photon has to travel distance of x minus 0, right? And we are ignoring y, I told you, just assume it's a one dimensional system. Time taken would be t minus 0, this should be x by t. What is the speed of a photon? Can anyone tell me? What is the speed of a photon? Can we generalize it?
Speed of light.
Speed of light. Very good. So I can write this to be c. And remember, c is a constant in whichever frame you are. We told this is a second postulate of STR, special theory of relativity. So I now know that x equal to, so let's write it here, x equal to ct. Just remember this expression. Right. Special theory of relativity also says that for a light, for a photon, or for a light, just hold on a second. Yeah, for any particle which is a photon, right, which travels with the speed of light, delta s is 0 for that. So we know from this special theory of relativity theory itself that delta s is equal to 0 for photon. So let's put that. So it will be c delta t whole square plus k delta x whole square is equal to 0 squared, right? So what I'll do is that delta t is nothing but t here, so ct squared plus k, delta x is nothing but x here, x minus 0.
Sir,
Yeah,
you put the k in order to check the sign of the k.
yes, correct.
So k will be determined.
I'm not able to hear you. Can you repeat?
Sir, in your equation you have written k because
Your voice is breaking. Can you please type? Just type it. Just type in the chat box. I'm not able to hear you.
He is asking, sir, when you are writing del s square is equal to c del t square plus k times delta x square.
Yes, yes.
He is asking you use k. Later you will find out whether k is positive or negative.
Yes, and also the value, whether it's 2, 3, 5, 10,000, what is it?
Yeah, that's what he is asking.
Yeah, because in the last class this was asked that why did I put a negative sign here? How did I come to know this negative sign? So I'm establishing that right now. Is the screen visible again? Just tell me. Are you able to see the screen? Yeah. Okay. So what I'll do is that, so c square t square plus kx square. Oh, I already wrote. Oh, never mind. So what I'll do is that, so I know ct equal to x. Okay. We just determined that due to the speed of light. So I'll write ct is x. So that will be x square plus kx square equal to 0. X square I'll take common. It should be 1 plus k equal to 0. Now note that x is a x is a real number first of all. So we can drop x square here and we'll get 1 plus k equal to 0. This implies k equal to minus 1. So we obtained k equal to minus 1. This implies our expression here will become delta s squared will be c delta t whole squared. Value of k is minus 1 minus delta x whole squared. So that's how that negative sign comes. So this is just a very simple proof of it. Actually, there are many papers written by physicists. I think first one was, I'm forgetting the name, in 1908. Someone first determined, they proved that this is essentially a negative sign comes. So that's how, but we don't need to worry about that. We just know that this is the formula for delta x. So I'll go back here. So we saw, yeah, so this formula that you see on your screen, this delta s square equal to c delta t whole square. This is a negative sign. That's how it comes. So any comments regarding this, because this was pending from the last class, and then we'll move forward for today's topics. Today we'll mostly focus on the transformations, that how is this related to this. Any comments about this? Okay, good. Now we'll move forward. Now let's forget about special theory of relativity for a minute, and we just talk about in the non-relativistic frame. So so let's say this is the frame S again, and this frame is S prime. So S prime is moving with at a constant velocity v with respect to this original frame S. So let's say I want to establish a relation between two events here. So let's say this event P1, which is x1, y1, z1, comma t1, and the same event will be P prime, but the coordinates observed will be x1 prime, y1 prime, z1 prime, t1 prime, right? So let's just assume that we are in a non-relativistic frame. Okay, so non-relativistic, such transformations are known as Galilean transformations, named after Galileo. Remember, both these frames will observe the same time. Okay, so t1 prime will be nothing but t1. However, x will translate. We have seen this. We have literally seen this when we change the frames of reference, like relative motion that we talk about in 10th class or 12th class. So this is exactly that. So the coordinate here will be nothing but x minus vt. Why x minus vt? Because this frame is moving at a distance vt for any given time t, and y and z will remain the constant. Why constant? Because motion is only in x direction. This is an, I repeat, non-relativistic regime. What do we mean by non-relativistic? That v is less than c. So c is 3 into 10 to the power 8 meter per second. V here can be, let's say, 10 to the power maximum 10 to the power 4, 10 to the power 5, or maybe 10 to the power 6 meter per second. Even then, v is less than c, and will still be in non-relativistic regime. So for instance, the rockets that are fired from Earth by NASA, by JAXA, by ISRO, by European Space Agency, all of those v is much less than c. Where we see v approximately equal to c? In CERN, the Large Hadron Collider in Europe. There, the velocity of subatomic particles are very close to speed of light, like 0.9 c, 0.8 c, 0.1 c, 0.2 c. So there it matters. So there they cannot use this. So what do they do there? We know in special theory of relativity, this remains invariant. Delta S space-time interval remains invariant across different inertial time frames. So we use this property to arrive at something called Lorentz transformation. So this is Galilean transformation. How is the primes related to non-primes? Similarly, Lorentz transformation connects how are the primes, how are the coordinates, space-time coordinates in this frame of reference, in S prime frame of reference, how are they related to the coordinates in this stationary S frame of reference. And gamma is a quantity which is denoted by this. Note that gamma is denoted by this. Okay. Okay, so now let's move forward. Yeah, so now what I'll do, I'll not derive this, but this can be derived, but I'll simply show you that this is conserved here for blue frame as well as for red frame. This is true. Okay, so I'll do that. So let's go ahead. So what I'll do is that I'll obtain the value of delta S square for this frame. Okay, and for the so let's do that. So delta S square would be, so again I'll assume that there's some event P happening at x1, y1, z1. Oh, let's say the event P is happening at x comma y comma z semicolon t. So delta S squared would be, I'll write the formula first, c delta t squared minus delta x squared minus delta y squared minus delta z squared. So it will be ct whole square minus x square minus y square minus z square. Now let's try to obtain the value of delta S prime square. Its value would be c delta t prime whole squared minus delta x prime squared minus delta y prime squared minus delta z prime squared. So c square delta t prime, what is the value? This is the value. So I'll put gamma square t minus vx by c square whole squared. Delta x prime will be nothing but x prime minus 0. So this will come out to be gamma squared x minus vt whole square. Delta y, which is nothing but y prime minus 0, which will come out to be y square. Similarly, this will come out to be z square. Okay, now what I'll do is that I'll open these brackets inside. It will be gamma square t square c square gamma square this will be plus v square x square upon c square minus 2c square gamma square tvx over c square. That is the first term. Second term, you will get gamma square x square minus gamma square v square t square plus this 2 gamma square x v t, okay, minus y square minus z square. So this term gets cancelled, you see, 2 gamma square x v t, this terms gets cancelled with this. And if, yeah,
why did you put value of t prime in place of del t?
okay, so
Because you have
okay, so because see, there is another event happening at q, so I'm assuming q to be at origin. So let's say this is at origin, so this will be 0 0 0 0. So what will be the delta x? X minus 0. Similarly, I'll assume q prime to be at origin here. Okay, p prime would be at x prime, y prime, z prime, t prime. So what will be delta x prime? Delta x prime will be x prime minus 0. That's why I did it. Is it clear? Hello?
yes sir.
Yeah. Okay. So what you do is you collect the t square terms. Okay. So I'll collect the t square terms. So t square term is here. So it will be c square gamma square, and the other t square term is here. So it will be minus gamma square v square. So it will be so if you yeah, so that's it. So if you solve this t square, we'll take gamma square common, so it will be c square minus v square, and let's put the value of gamma. Gamma is 1 over 1 minus v square upon c square. If you solve this, it will be c square minus v square. It will come out to be c square times t square. So t square coefficient is c square, which we see in this expression here. Similarly, if you try to obtain the coefficient for x square, it will come out to be 1, because this term plus this term, this and this, if you do the mathematics, it will come out to be exactly minus 1. I'll do that, it's fine. So it will be x square, if I take common, it will be c square gamma square v square over c square minus gamma square. C square gets cancelled, so it will be, if I take gamma square common, c square gamma square, this is just hold on a second, I'm missing a square term somewhere. Yeah, it will be c to the power 4 here, sorry. Yeah, so it will be v square by c square minus 1. Let's put the value of gamma square here. Gamma square is nothing but this 1 minus v square over c square, and this will be v square over c square minus 1. This gets cancelled with this with a negative sign. So x square coefficient is coming minus 1. So I am getting c square t square minus x square, and you see this term minus y square minus z square. So what I have done is that I have proved that this is correct, because this equation is being satisfied. So this transformation is correct in special theory of relativity, where we are talking about two inertial frames. And this, what you see on your screen, this thing, this in the top center top of the screen, these are nothing but Lorentz transformation, which is I've written here also without the clutter. So you so what you must do is that you must remember this expression. Now there is a trick to remembering this expression. This is fairly easy to remember. This is your high school physics, right? Just multiply it by gamma, so you get the x prime. Similarly, to get the t prime, you negative, remember there's always a negative sign, gamma always comes in front, and in order to balance the dimensions, you have to multiply it px by c square. So that's the trick. Just you have to find your own tricks to remember. That's how I do it. So but you have to remember this formula, and remember y and z did not change because the movement was in x direction. So please note that if the movement is in y direction, x prime will remain the same. If the movement were in y direction, so what will happen is that there will be, say, x prime equal to x, but y prime would be equal to gamma times y minus vt. Very simple. Just x and y are interchanged, because there is, see, x and y are for our convenience, and so just these are equivalent entities. So that's about it. Now what we'll do is that we'll go through one of the questions that was asked in GATE Physics 2016. Before I go through this, I'll pause for a minute, and I'll ask if you need me to repeat anything, some specific step which you did not understand, or some specific term you have a doubt about. So I'll pause here for a minute or two, and just process it and ask me if you have any doubts. Okay, Anuj.
Yes, sir. In the last step, could you please go? Yeah, they are taking that is in the after the delta s square is equal to delta s prime square. That is the main black heading, right?
Yes, yes,
Below that we have taken t square and c square gamma square minus gamma square v square.
yes.
So that is the where we got from get.
So we got it. Okay, good. So you see this term here,
Yes, sir.
coefficient of t square. So this term is the same as this. Okay, you see
Okay,
t
sir.
square, and the second t square term comes from, where is the second t square term? Here. This is t square, right?
Yeah, yes.
So this goes here. This is t
Okay.
square coefficient minus gamma square v square. So this is how we got here. Okay.
Okay. Yes, sir. Okay.
Similarly for x square, so you collect the coefficient of x square is here and here, so you collect it here, and then the rest is simple, very simple, just algebra and substituting the value of y, right? Okay, okay, then we'll go ahead and try to solve this problem. So before it's important to be just to keep some few things in your mind before you solve any problem related to special theory of relativity. Just try to see how many frames are there, and whether they are initial or not. So you see, are you able to hear me or see my screen?
Yes, sir. You are
Okay,
audible.
so it says that there is inertial frame of reference S. Okay, so I'll draw that frame here. So there is an initial frame S. Very good. It finds two events. So an observer is sitting. Let's assume, as always, the observer is at origin. Finds two events occurring at the same time. Okay, so this fellow is two events P and Q. And first event is P, second event is Q. They are happening at the same time. So we don't know what time, but they are happening at the same time. First coordinate is 0, second coordinate is t. Again, see, we are ignoring y and z. Why? Because the motion is in x direction. How do I know it's in x direction? This question says so. A different inertial frame. Okay, there is a second frame now. It is also inertial, S prime. So once we have established that it uses only inertial frame of reference, then only this Lorentz transformation and all the things we have talked about, space-time interval, is valid. Otherwise, it's not valid. So this frame S prime is moving velocity v with respect to s in positive x-axis. Very good. So this is our all theory has been. This is moving at some constant velocity v. Doesn't matter what the velocity is. We'll say it's constant. And again, we'll assume observer is at O prime. Observer S prime. Also notice these two events. I told you, whatever events are happening here, they will be observed in some form here also. Yep, Mandlik. But still we'll go through these steps so that everyone can understand, because once you go through, I told you in the first class that I only have 2 or 3 formulas and only one approach. I cannot remember the shortcuts, so I follow these steps in every special theory of relativity question. S prime also notices these two events. So let's say first is P prime, it's Q prime. What are the coordinates? We don't know. Let's say it x1 prime and time is t1 prime, x2 prime, time is t2 prime. Again, I am ignoring y and z. Why I am ignoring y and z? Because the motion, it's only in x direction, so it's a one-dimensional problem, so to speak, right? And the coordinates are given t1 prime, t2 prime, x1 prime, x2 prime, which I have written here, and also given delta t prime is t2 prime minus t1 prime. This is what we also assume is the nomenclature we follow. Similarly, this gamma is given, 4 options are given. This is a multiple choice question with one correct answer, and we'll try to find the correct one. So this is the problem. So the most key thing here is that this term inertial, right? This is the only important thing. And the second thing important here was this occurring at same time. So a synonymous for occurring at same time, some of you may know, is simultaneous. Simultaneous means any two or more than two things which occur at the same time. The time coordinate is the same, right? Yeah. Okay. So now let's go ahead and yeah. So this was the problem given to us. This is our first inertial frame S, in which first event was P at coordinates 0, t1. Second event is d, t1. Similarly, here I have another inertial frame S prime, and observer O prime is observing these. right? So we need to find delta t prime, which is t2 prime minus t1 prime. Now if we find t2 prime and t1 prime and we subtract them, we'll find our answer. Similarly, if we find x2 prime and x1 prime, we'll find our answer. How do we find t2 prime, t1 prime, x2 prime, x1 prime? By using Lorentz transformation. These are the Lorentz transformations, right? So first what I'll do is that we'll try to find the x primes. Okay, so that's what I'll do here first. So I'll do x1 prime using this formula. This will be gamma times x1 minus v times t1. I have just nothing but put 1 in the subscript everywhere. I have also put v1, but there's only one velocity. This is the velocity v. So this will come out to be gamma. Gamma remains constant. What is the value of x1? The value of x1 is 0. So I'll put 0 minus v times t1. What is the value of t1? The value of t1 is t1. We don't know this time, but we know these are simultaneous. So whatever the value, it's the same. So it will come out to be minus gamma v t1. Now let's find x2 prime. So x2 prime would be gamma x2 minus v t2. What is the value of x2? x2 is d. We see here. So d minus v. What is t2? t2 is nothing but t1 here. We know. So this will come out to be t1. So this will come out to be gamma d minus gamma v t1, right? And we need to find delta x prime. So we'll do delta x prime is nothing but x2 prime minus x1 prime, which will come out to be gamma d minus gamma v t1 minus gamma v t1. Gamma v t1 gets cancelled out and we'll get delta x prime equal to gamma d. So I'm writing this value here. So this is the first part of the question. Let's see if there are any options like this. There are. Delta x prime we find out to be gamma d. So either this is correct or this is correct. This is not correct. This is not correct. So we'll also have to find delta t prime. It's a good practice to eliminate options whenever you can, because sometimes if let's say this option were also d by gamma, then you need not even solve for delta t prime. C would have been the correct option, right? So yeah, so where are we? Yeah, we are going to find t2 prime and t1 prime. So again I'll write the formula. T2 prime, this formula, this will be gamma t2 minus v2, but there's only one velocity, x2 over c square. So what's the value of t2? T2 is this. Yeah, T2 is this. So this will be t1 minus v. What's the value of x2? x2 is d. Remember that 2 corresponds to q, right? The event q and q prime here. So vd over c square. So this is t2 prime. Now we'll get t1 prime. Again, first I'll write the formula gamma t1 times vx1 over c square. What's the value of t1? This is 1. So t1 is t1 minus v. What's the value of x1? The x coordinate of event p is 0. So times 0 over c square. So this will come out to be gamma times t1. We were required to find delta t prime. So delta t prime would be t2 prime minus t1 prime, which will be equal to gamma t1 minus gamma vd over c square. This is the t2 prime, minus t1 prime is gamma t1. So gamma t1 gets cancelled. We'll get minus gamma vd over c square. This is the value of delta t prime. So I'll write this value here, minus gamma vd upon c square. So do we have any such option? Yeah, we have already eliminated these two. Remember that. This was this, and minus gamma vd over c square. So C is the correct option, right? So that's how we try to approach this problem. I'll just repeat the steps one more in brief. Just make sure the frames are inertial. So S is inertial, S prime is inertial, right? And see which direction is the relative velocity is. So relative velocity is in positive x-axis. It's a constant velocity v. These are inertial, so it means it's a constant velocity. Positive x-axis. And the important thing here in this question was this, same time or simultaneous. This is a very straightforward question where we just used one single formula, this. And we obtained, it did not even require solving some square roots or use of calculator, nothing. Just you have to remember these expressions, put the values, don't hurry, put the values, and you will get the answer in less than 2 minutes, which is more than sufficient time for GATE exam or NET exam. So that's that. So I'll pause here, and I'll ask you to just take a breath and just let me know if you have any doubts or any comments in this problem or anything you want me to repeat. I'll just pause here. Go ahead. All right. Good. We'll now move to the next problem, which happens to be similar to this problem. See, why I always emphasize going to the previous year problems. Look at this problem. Two frames S and S prime simultaneous. Look at this question. So this was from 2016. This is from 1 year before, 2015. Inertial frame S, right? TA is 0, TB is 0. This means there are simultaneous events. And again in the next year they asked the same question. Simultaneous events question was asked in 2015. Same question was repeated in 2016. It happens. The questions repeat themselves. That's why I emphasize you go through the previous year questions for physics, for gate, for net, for just for anything. Sometimes you just change the values a bit, and sometimes here it's a numerical. In this 2016 question, it's analytical more or less, but the question remains the same. So again, we'll again try to solve this problem. I know only one approach, and we'll solve using that approach. So what does it say? This is an inertial frame S. Okay, so I'll draw an inertial frame S. This is S. Observer is sitting here. Two events take place, A and B. So first event here is A. The coordinates are given. Okay, sometimes the coordinates are written in CTA form also. You need not worry. Just keep the C along with the time itself. It won't matter. And RA equal to 0. Note that there's a vector here. What does this mean? We are talking about 3D space here. We are talking about 3D space. So this essentially means XA, YA, ZA. Right? So it's 0, 0, 0. Right? So I'll write it as 0, 0, 0, semicolon. The time is 0. We know the time is 0 here. TA will come out to be 0. Second event, B, it's also happening at time 0. So first I'll put the coordinate as 0. Yeah. So first, yeah, we'll get to that option, Shantu. Where was I? Yeah, so coordinates for RB. Now again I told you this vector is in the space, the 3D space that we usually X, Y, and Z. So its coordinate is 2y cap. What do we mean by that? 0, 2, 0. And the time coordinate is 0. So I have already written the time coordinate. The space coordinate is 0, 2, 0. So I have written the first statement says inertial frame S, two events A and B, and I have produced them here. Now the question is at which times these event takes place in a frame S prime. So there is another frame S prime. Here it is. And the question is it inertial or not? We don't know yet. The question has not said anything. It says moving with a velocity 0.6 c y cap. Okay, so we know the velocity v of this frame it's in y direction. Note this y cap. So this is x, this is y. Similarly, this is x prime. Note everything is primed in the second frame, and it's moving in this direction. Velocity v equal to 0.6 c. C is the speed of light. So we notice that this is a constant velocity. It will come out to be what? 1.8 into 10 to the power 8 meter per second. It's a constant velocity. This means S prime is also an inertial frame. It did not explicitly say that, but since it's moving with the constant velocity, S prime is moving with the constant velocity with respect to S, we get to know that S prime is also an inertial frame of reference. Hence, all the expressions of Lorentz transformation is equally valid in this frame. Okay, so it's given here, and we need to find the coordinates of TA prime and TB prime. We see we do not bother about x and y coordinates, space coordinates. We only need to know about the time coordinates. So I'll write the first event here will be A prime. Let's forget about the space coordinates, and I'll write it as TA prime. Similarly, second is B prime. Forget about the space coordinates, and we'll write as TB prime. And we need to find what is TA prime and what is TB prime. Right. I'll again just clarify the question. Two frames S and S prime. First is at rest, so it's inertial, it's given. Second is inertial because it's moving with a constant velocity, but note it's in y direction, 0.6 c, and we need to find the time stamps of these two events, A prime and B prime, in this frame. So this is the question repeated here. Again, I have dropped, you notice I have dropped the x coordinate and z coordinate. Note that I have dropped the x coordinate and z coordinate because they're irrelevant to this problem. The only action happening is in y direction. So that's why you see these terms. So 0 and 2 y cap, and the time stamps for 0 and 0. These are called simultaneous events. I talked about in previous problem also, but I'll reiterate. This term might itself be a question, simultaneous events. And these are the coordinates in the S prime frame, and it's moving with velocity v. Note this direction is y cap, so I've just simply flipped the Cartesian coordinates, which you can rotate easily. And we need to find Ta prime and Tb prime. How do we find Ta prime and Tb prime? Again, very simple. We know the formula, Lorentz transformation is valid because both these frames are inertial frames of reference. So again, this is now just a problem of putting the formula itself. So Ta prime would be gamma times Ta minus V xa upon c square. Just repeating the formula itself. So this will come out to be gamma times the value of Ta is this, it's 0, minus V xa is 0 times 0 over c square. So this will come out to be 0 minus 0 will come out to be 0, let's say unit seconds or whatever it is. Tb prime, right? Tb prime would be again gamma Tb minus V xb over c square. Using this formula again, it will be gamma, the value of Tb is 0 again. I'll put 0 minus V xb is the I should not do this. Since this is action is happening in y direction, so this formula will become T prime gamma T minus Vy over c square. So this is Ya actually, and this is Yb, and this formula is not correct here. So it will be y prime equal to gamma y minus Vt. X prime will be equal to x. So note that x and y simply swap the places, so nothing else will change, so everything else remains the same. So Ya was 0 here, 0 y cap. Similarly Yb here is 2, so I'll put V into 2 over c square. So this will come out to be minus 2V gamma over c square. And okay, so Ta prime is 0, Tb prime is minus 2V gamma over c square. And now we need to find the value of gamma. Gamma is this, so I'll try to find the value of gamma over here. Just 1 over 1 minus V square upon c square. So 1 minus V is 0.6 c, so I'll write 0.6 square c square upon c square. C square gets cancelled. It will be 1 minus 0.36. 0.6 square is 0.36. It will be 1 minus 100 minus 36, 64. 0.64. 64 square root is 8. So this will be 1 over 0.8. The value of gamma is 1 over 0.8. I'll put this value here. So it will be minus 2 multiplied by V. V is 0.6 c. 0.6 c. Okay. Yeah. 0.6 c times gamma. Gamma is 1 over 0.8 divided by c square. So this gets cancelled, and what we'll get is 2 into 1, this 1.2 over 0.8. So this is minus 1.5. So this is minus 1.5 is 3 by 2c. So what I'm getting is that Tb prime is minus 3 by 2c. And what is Ta prime? Ta prime was 0. So I got Ta prime was 0 and Tb prime was minus 3 by 2c. We need to find the value of in Ct. So this will be, we take the c to the other side, it will be minus 3 by 2, and this will obviously will remain 0. So the answer is 0. Ta value is 0. So all the four options have Ta prime as 0, sorry, and the value of Tb prime is minus 3 by 2, which is this option. So option A is correct here. So again, I'll go through briefly through the question again. First frame inertial given S, and two events were taking place. with simultaneous events, because Ta and Tb are the same. Then we need to find the time stamps of these events A and B in some other frame S prime, which was moving in y cap. Note, not x cap but y cap. And we needed to find the timestamps, so we found the timestamps using this formula, T prime equal to, so this was Vy actually. So this is the correct formula here, because action is happening in y direction. So T prime equal to gamma, I'll write this here, T prime equal to gamma T minus Vy over c square, and y prime would be gamma y minus Vt, because velocity is in y direction. That's why we use these two formula here. And we just put in some values, and we also calculate the value of gamma, did some algebra, and we find out that A is the correct answer. Now I need you to pause a bit here and notice that although these events were simultaneous in frame A, they're not simultaneous in frame B. Note that there's a difference, there's a finite time difference here, right? So this finite, so this means that this is what happens in special theory of relativity. In normal time, if I ask each one of you what is the time, you will say it's 7:51 p.m. more or less, depending on how our clocks are synced to the satellite. You will more or less say 7:51 p.m. It is not the same when we're talking about special theory of relativity. There the time moves hugely, because we are moving very close to the speed of the light. And this is why this is different, special theory of relativity. When humans sometime, hopefully in future, evolve to speed through the universe, maybe this theory will have some practical impacts. It does have some practical impacts, but not so much in real life. For instance, the astronauts in space, they age differently from us normal humans at Earth. It's a fact. They age differently. It's a difference of nanoseconds, but they do age differently. Maybe we'll see in the next class. I think there's a question related to that. Right. So something we saw Lorentz transformation. What did it mean? Lorentz transformation converted. We could find out the primes in terms of the rest frame. So this is S at rest. This was S prime moving with a constant velocity v in positive x direction. And we noted we could find out the prime ones, right? Note, LHS is prime. We could find out these with respect to the rest frame. What happens if the situation is inverse? Let's say you were given coordinates for this. You were given coordinate for this event P, x, y, z, comma, primed x1, and you were required to find value of x, y, z, t, and you were required to find x is equal to what, t is equal to what. What happens then? Simple, man. This is nothing but this is two equations. Forget about y and z. This is two equations and two variables. Here the t prime and x prime will become the known, and t and x will become the unknown. Two equations, two variables. If you try to solve it, just algebra, nothing else, just algebra, you will get something what is called inverse Lorentz transformation. Why are they called inverse? Because now we are finding non-prime entities in terms of prime entities. How do we get this? Again I repeat, this is nothing but simply whatever you have here in these first two terms, you just assume t and x to be the unknowns, t prime and x prime to be the knowns, and when we rearrange, you'll simply get these two terms. So how to remember them? Note that the form is very similar, except this minus sign here. Minus sign has become plus. Note, minus sign has become plus. Everything prime and non-prime will become, they will change the prime. So this t prime will become t. Here t is becoming t prime, x is becoming x prime, and the sign changes. So if you remember this, there's even no need to remember this inverse Lorentz transformation. It's very straightforward to just do some rearranging, and you will get the terms here. Right, just like we proved in case of, remember, in Lorentz transformation that we saw that delta s square was coming at delta s prime square. What I'll do is that I'll again do that here, just so that why I'm doing this again and again. This will never be asked in the problem. I need you to appreciate this. The space-time interval is the most fundamental thing in special theory of relativity. The invariance of space-time interval is the most fundamental thing. Everything is linked to this. Everything is derived from this in special theory of relativity. So even if you don't know anything, if you just know this, you can arrive at any formula for special theory of relativity. But I'll still advise you to remember the formula, because you're giving competitive exam, right? For interviews, you may need not remember. They'll ask you, okay, they'll help you in interviews. So again, let's try to derive this delta. Let's try to evaluate the expression delta s square is nothing but c delta t square minus x delta x square minus delta y square minus delta z square. Again I'm assuming first to be 0 0 0 and 0, and this to be x y z and t. This will come out to be c square t square minus x square minus y square minus z square, right? And I'll put these values here, right? Because these t prime and x prime are knowns. Remember, t prime and x prime, we know their values, knowns, we call them knowns, and t and x are unknowns or dependent variables, whatever you want to call them. So I'll replace the value of t as this here, so it will become c square. Value of t square is gamma square t prime plus vx prime over vx prime over c square whole square, minus the value of x is gamma square x prime plus vt prime whole square. I'm just dropping y and z, it will not change the algebra much. Again I'll open c square gamma square t prime square plus c square gamma square v square x prime square over c to the power 4 plus c square gamma square 2 t prime vx prime over c square, minus will come out to be gamma square x prime square minus gamma square v square t prime square minus 2 gamma square x prime vt prime. C square gets cancelled, and this whole terms gets cancelled by this term. Note x and t here, x prime t prime here, x prime t prime here, 2 gamma square v, so this gets cancelled. Again I'll collect the t prime square coordinates, terms, so it will be c square gamma square, this first term, this term here, and again t prime square is coming here, so it will be minus gamma square v square. I'll take gamma square common, t prime square will come out to be c square minus v square. So if you try to put the value of gamma over here, so this will come out to be c square will come here, will be c square minus v square into c square minus v square, so it will come out to be c square t prime square. So the first term has come out to be, I'll write there, c square t prime square. Similarly, if you solve the second term, what we'll get eventually, so I'll just write the x prime square terms here. So x prime squared is c, so it will be gamma square v square over c square, this term here. Second term is here, so this is minus gamma square. This will come out to be minus gamma square x prime squared, and this will come out to be v square over c square minus 1. This is nothing but minus gamma square. So if you put it, it will be, this is the value of gamma, x prime squared v square over c square minus 1. This will get cancelled with this. There's already negative sign here, so it will come out to be plus, so it will come out to be minus x prime squared. I think I missed a negative sign here. I took the negative sign out here, that was a mistake, so there's no plus here, so this is plus, come out to be minus x prime squared. This is nothing but, note that c, so if I try to find out delta s prime squared, this will be c squared t prime squared minus x prime squared, and this is the value that we obtained here. This is nothing but delta s prime squared. Again I'm ignoring the y and z. Even if you add it, these are just two extra terms, they do not play any role in this formula over here, right? So again, using just these expressions, I again evaluated that the space-time interval, even if you use this inverse Lorentz transformation, space-time interval remains invariant, which means these formulae are correct. You don't need to remember them, you don't need to remember this proof. The idea is to just emphasize again that why is this important. Invariance is the most important thing in special theory of relativity, right? Maybe next class we'll see this length contraction and time dilation. These are very too important. These are real life impact that we see. I told you time dilation happens like when an astronaut is there in space, so they do experience, but very nanoseconds. It's not relevant in human time scale, which is average is around 70 years. So this is not matter. But when we travel to speed of light or for long times, this matters. We'll see these things in the next class. But for now, I'll end here. And I'll again ask you, if you have any comments, any questions, please go ahead and ask me. from my side, this session is complete, and thank you for your patience hearing. Yeah, go ahead. Okay, if no comments, then we'll close the session for today. As I told you, I'll again write my email ID and my YouTube channel here. You can go through the why YouTube channel. You can go through these previous videos. For instance, my previous 12 lectures were on electronics, and last lecture was on special theory of relativity. So if you have any doubts, you are welcome to add, leave comments, ask questions, discuss, not with me, with yourself, anyone, however you feel comfortable. If you don't feel comfortable asking questions on a public forum, I have written my email, I've also shared my email address. Yeah, so that's all from me. Next class will again be on special theory of relativity. In that class we'll maybe go, today we saw how x and y are transformed, right? Next class we'll see how velocities are transformed, because velocity is rate of change of time, delta x by delta t. So we'll see that how are those transformed. So we'll see to that. If you have any doubts in for any other exam, please drop an email, because it's good to ask, to discuss questions in these sessions, concepts as well as questions. If you have any doubts from some other exam, I'm more than happy to discuss it, because we have some time at our hand. So yeah, thank you for your patience, thank you for listening. We'll see you again next week. Good night.
Yeah, thank you, sir.
Bye bye. Good night.
Thank you, sir.
Welcome everyone. YouTube link, okay, I'll share. Here's the link, Mandlik. You can go through this link, and yeah, that will be all. Yeah, welcome. Thank you. Good night everyone. I'm closing the session. If you have any comments, please speak now, otherwise I'll close. All right, good night everyone.